There we go. Okay, great. Welcome everybody to the first of our what will be a weekly series of Rubin Science Assemblies. I'm Jeff Carlin. I'm the Deputy Lead Community Scientist presenting on behalf of the Community Science team. We called it a reintroduction to data previews 0.2 and 0.3, meaning if I see some familiar names and faces here, for many of you, it may be kind of review of things that you already know, but it's always good to have a refresher. And then for those of you who are new, I see lots of new names and faces. We will give you, this will be kind of a whirlwind introduction, but at least it'll hopefully familiarize you with the resources that are available so that you can learn more. Come on, there we go. All right, so, okay.
Recording on. Recording's not on yet, right, Jen?
It should be recording.
Oh, okay, great. Oh, I see it.
Did
Never mind.
you not get the notification?
Yeah, I see it. Yeah.
Oh, good.
Yeah.
Yeah, so we'll just have a couple of announcements and then a presentation, which will be not necessarily a formal presentation. I'm just going to go through a lot of the resources. And then what you see here on the alternating weeks, when we don't have presentations, we will have basically staff from Rubin available here for sort of Q&A, for troubleshooting help, and we will provide, you can create breakout rooms and work with people on science projects, for example, or any explorations that you want to work together with people on. So I encourage you to think of ideas of things you want to work on, and maybe things you want to work through with others. We will provide you the space, and we'll be here during those alternate week assemblies to help you with any questions that arise. So just a couple of quick announcements. One is that the 2024 Rubin Community Workshop is scheduled for late July this year. It will happen at SLAC at Stanford in Northern California, and we'll also have a hybrid component. There is a link here to the community forum post with more details about how to propose sessions that you would like to see at the workshop and to contribute abstracts for both posters and talks. And the registration, look for an announcement. The registration will open very soon. I also wanted to note that since I do see a lot of new faces here, or new names mostly, if you recently started the process of getting set up with a Science Platform account, but you haven't yet been able to log in, let us know in the Zoom chat and we can check on that. And we have a few people from the community science team here who can check on that and approve your account if it's still waiting. And finally, I wanted to mention that we have a Rubin Data Academy coming up this summer in June. This is sort of the equivalent of what last year we called the DP0 Virtual Summer School. This will be a week of presentations, tutorials, and co-working sessions where you can hack together with people and work through tutorials or develop your own new science explorations together. More details are coming soon on this. We're just starting the planning process, but that'll be the week of June 17 through 21 with one day off in the middle of that for Juneteenth. So it'll be 4 days out of the 5-day week. I wanted to briefly introduce you to the community science team. The lead of the community science team is Melissa Graham, who is here with us, and I'm the deputy lead of the community science team, but there are many of us making up the community science team. And you'll see many of us here right now, and week to week, you'll see many of us appearing. We are here to help you, to enable you to do the science that you want to do. So do feel free to reach out to any of us with questions. And I will say that this team has members that have expertise in a wide variety of science areas related to Rubin science, as well as specialists in documentation, research inclusion, citizen science, and other topics. So just wanted to put face with the names. Okay, and so the rest of this time, I want to basically take you through some of the documentation and the resources that we have available. And I put a bunch of links here, and we can put the link to these slides so that you have access to these links. We can put that in the chat soon, but this has links to a couple of brief videos that are on our YouTube site that you can watch that goes through a lot of the stuff that I'll be going through today. The main resource sort of landing page for our documentation is DP0.lsst.io, and then we'll talk more about the community forum and the science platform here in just a little bit. And we've also included here the resources for more information about the simulated survey, which makes up data preview 0.2. So this is a convenient set of resources for you. So I'm going to start off here by just, moving over to our newly launched website at dp0.lsst.io. And this is what it looks like when you reach the splash page. So you'll see here there's sort of three branches that you can take once you get here. There's the main sort of set of resources for you, the delegates. And then there are separate sites for data preview 0.2 and 0.3. So this is because these are completely independent simulated data sets. So the documentation is separate for those. So those have, and anything related to each of those is found on their dedicated sites. And you can also see at the bottom of the page links to the science platform and to documentation of the science pipelines that actually do the data processing. But first, we're going to go to the delegate resources. And many of you may have already gone through this, but for those who haven't, I just wanted to take you through the getting started with data preview 0 checklist. If you're not yet a delegate, it's a very simple process. You just follow this checklist, and you will be set up with an account in the Rubin Science Platform. You'll hear us say RSP a lot. That's the Rubin Science Platform. There's not an application process currently. If you apply and you are a data rights holder, then you will be approved. And if you're not familiar with what the data rights requirements are, you can go here to the participation guidelines in step 1 of your checklist. And so this has, so you must be a Rubin data rights holder and abide by the data rights policy, of course. And what that means is if you are affiliated with an institution in the US or in Chile, you have data rights. Also, if you're an international scientist or student whose name appears on this list that is linked here of international data rights holders, you also have data rights and are eligible to have an account. And there's a link to the policy about this. And if you're uncertain, you can always send a message on the community forum or directly to Melissa. We also want to remind you that you know, our survey has not yet begun, so this is a developmental version of the science platform that you'll be using, meaning that there are some risks and caveats, and I encourage you to go read those. Not that, you know, anything dire is going to happen, but just that this is an in development system, so things are kind of changing underneath us as we go a little bit. And I also encourage you to read and review the Rubin Code of Conduct. And there are links here if you experience any sort of violations of this code of conduct. There are links here for how who you can contact about that. Okay, so if you have not yet and you would like to, the second step in the new delegate checklist is to petition for an account in the Rubin Science platform. It's a very simple process. You basically just give your name and your institutional email, and right, if you do it right now, I think that operators are standing by. Melissa could probably approve your account right now if you've not done so. Otherwise, it might take, you know, a short time, you know, a day or two, a couple days to get approved. But then once your petition is approved, you can log into data.lsst.cloud as a DP0 delegate. So if anyone has submitted the petition but not yet seen an approval and been able to log in, let us know, and we can finish that process for you right now. And of course, you can do it now as we are speaking. Okay, and the third step is to get an account in the Rubin Community Forum. The Rubin Community Forum is our platform for you to communicate with each other. It is at community.lsst.org. This is what you see when you go to that web address. Anybody, whether you're a data rights holder or not, anybody can create an account. It's free. You can create an account. And this is where you can both ask for support and also just discuss. You can discuss science with the global community of scientists interested in Rubin. You will also see a lot of announcements here. So in fact, like here's an example. Here's an announcement of a talk happening next Thursday. Importantly, as I mentioned, you can get support here. You can see when you log in, or when you, I guess, reach the page, one of the first categories you see listed here is support. Now you can click on this, or you can see that there's also, it has a subcategory specific to Data Preview 0. So there's both general support and there's the Data Preview 0 support category. So this is where you can get, you can ask for support, and Rubin staff will always be monitoring this channel, but also, you know, the community of delegates and scientists may also see your message and be like, oh, I had that question too, and here's what I found worked. You know, this is meant to be a community where you can all assist each other in finding solutions. But of course, in the support categories, the Rubin staff will be also monitoring that and there to help. And you can see here there are also categories for science discussions. If you join a Rubin Science collaboration, which we'll talk more about in a minute, each of them has their own private group. You can see there are lots of other categories here. And you'll see the posts that appear. Let's take a look at an example. So this is what the topics look like when you post one. You can assign them to categories. I can show you here if we go to a reply. here's what the interface looks like to reply to one. I guess I could, instead of replying, let's go and create a new one, just to show you what that looks like. So you can go to this new topic button. And so, you just give it a title. You can pick categories. You can apply tags to it. So you can see there's like a DP0 tag and many others. And then, okay. Let's see if I do that. And you see what it's going to look like, and you post it, and it will look like the one that we just looked at a minute ago. Oops, I said discard. Okay, so I encourage you to in the banner at the top here, I encourage you to familiarize yourself. You can see we have a user guide. We have some how-to topics teaching you how to do different things. There's even an interactive forum tutorial with a little bot that leads you through aspects of it. And of course, there's information here about support. And there are also links to different avenues to, for example, advertise events, to news categories, how to watch certain topics so that you'll receive email notifications if you'd like. So I do encourage you to familiarize yourself with the forum and use it for, it can be as small as just like, hey, the query that I did seemed like it should be quick and it's taking a long time. Is anyone seeing slowdowns right now? Or it could be something broader about science or anything else. So there are notes here. There's actually a link to a brief video showing how to navigate and post topics as well. Okay. Before going on, I want to make sure there are no questions. I don't see any in the chat. Okay. So as a delegate, I guess we have some suggested sort of activities for you. We have a lot of tutorials, which you'll see a little bit more about in a minute, that you can work through that help you familiarize yourself with the science platform and the tools and the data sets that are available. We have a lot of documentation so that you can, for example, learn more about the data model and things like that. And we encourage you to dive in and use as much of the information as is available, or as you wish, to prepare yourself for real commissioning data that will be coming with Data Preview 1 and Data Preview 2 within the next year. So you can prepare yourself so that you can really hit the ground running when real data appear. So there's lots of documentation. There are tutorials, which you'll see a little bit more about, but we're constantly developing new tutorials. We have these science assemblies that happen this time every Thursday for 1 hour each week. And as I mentioned before, they'll alternate between presentations and sort of open Q&A and co-working time. And of course, we have the Rubin Data Academy that I also mentioned coming up this summer. And basically, one of the purposes is for you to develop your skills so that you're ready to hit the ground running and do science when real data start flowing. The other is to help inform the project on improvements and modifications that we can make to the science platform. So you're helping us develop and sort of enhance the tools that we provide to the community. And so there are, there will be feedback surveys that will ask you for feedback if you have any. And we do have also a users committee that their purpose is to take feedback from the community and advocate on your behalf. So I do encourage you to reach out to the users committee if you have any feedback at any time. I also wanted to mention that if you have bug reports that are more of a technical nature than the sort of things I mentioned when we were talking about the community forum, those we actually have a let's see, a site on our GitHub that you can submit support tickets here. And so this is a more official way of asking for support when something is not working. And so you can see from that link, it takes you to this page with some instructions for how to create a bug report. And so you can, if I go here to issues, you can see these are issues that, and this will be, the science platform team will see this and address these directly whenever you have an issue. So that is the other way for you to get help. You can also suggest features. And of course, in the community forum, share your experience and discuss amongst yourselves as much as you like. Okay, so one additional thing I wanted to mention is that in addition to the tutorials that we, the community science team, produce to walk you through different aspects of using the science platform, there are also tutorials or science explorations that DP0 delegates like you have contributed. I see some folks who have contributed those in the room right now. So you can go, for example, to these repositories here and see that that there are a number of different tutorials and science explorations that have been submitted by the community, and you are encouraged to do so as well. You can learn from your colleagues who have kindly made these available. You can also perhaps be inspired to start up a collaboration with somebody if you have shared interests. So I encourage you also to check out those, where are we? To check out those delegate contribution notebooks. Okay, so if I go back to the main page, very briefly, because we don't have a ton of time today. Before I continue, actually, I just would like to pause and make sure, see if anyone has any questions or comments that you would like to make before we move on. Okay. So very briefly, I'm just going to give you a really quick introduction to what the two Data Preview 0 data sets are and how you can learn more about them. So if you go back to the dp0.lsst.io page, you can click on this box and be taken to the DP0.2 webpage. And this has much, I guess some of the resources material will be the same as what you see on the that we've now consolidated on the dp0.lsst.io site. But what you also find here is documentation of, what is this data set and what are the data products that are provided to you. And you also can see links to the science platform and some introductions to the different aspects of the science platform and data processing tools and such. And then you see introduction, or you see links to tutorials. So we'll come back to that in a minute. First, I wanted to just briefly mention that if you go to the DP0.2 data products, this is where you can learn a lot about the simulated data set that makes up Data Preview 0.2. That's based on the Dark Energy Science Collaboration, the DESC, simulated about 300 square degrees of sky to basically the depth that we expect after 5 years of LSST survey. And these are extremely complex and detailed surveys meant to sort of realistically simulate most aspects, I guess, of what our surveys data will look like. And so it was, it was a lot of work, and we're very thankful that the Dark Energy Science Collaboration allowed us to make these available for you as a sort of data preview training set. So this contains fairly realistic populations of galaxies, including large-scale structure. It contains Type 1a supernovae. It contains a model of contains stars in the Milky Way based on a model of the Milky Way. And some number of those stars are variable stars, such as RR Lyrae variables and Cepheids and others. There are things it doesn't contain, but you can't simulate everything. But it is a very useful data set to get you started using our tools. So there's more information here and lots of links to how the data processing was done and everything. I will not go through those right now. I did want to mention, though, that the data products definition document here is your friend. It will, oops, here we are. This will tell you what the different data set types that you'll find within our data set mean. So you'll see something like CalEx, but if you're like, what does that mean? This is your reference. So in this case, a CalEx is a single visit image of the sky that's been processed with the instrument signatures and the background removed. And then there are deep coads, for example, which is of course the stack of all the images overlapping a region of sky. And there are various other templates for difference imaging and other such things. So there's lots more information here. There's information about the footprint of the simulated sky. So if you're ever trying to figure out a position that overlaps this footprint, this map is very handy for you. The other thing, besides the data set types for images, is the catalogs. There are various catalogs available to you. And so this is, again, your resource for that, where the different catalogs are, the object catalog, which is what comes from the detections and measurements from the co-added images. So this is the deep co-add images, and you can see this has 990 columns worth of different measurements. The source table is from the single visit images. And then we have other things such as forced sources. We have this dia object, dia source. The DIA is difference imaging analysis. So these are things detected and measured on difference images where you subtract a template from the visit image, and various other tables, including, because this is a simulated data set, including the truth tables of what was actually simulated. And so there's some guidance about if you want clean photometry of point sources or you want good galaxy photometry, for example, there's some guidance here about what to do for that. But I'll also go back up here to the table schema, if you want to know what all of those 990 columns in the object table mean, you can go to this schema browser, which I just opened in a new tab here. And now you can see that the object table, for example, this is object table highlighted now. This will show you what the definitions of all of those 990 columns. And so, you have here the declination coordinate is defined. So if you're ever looking, trying to figure out which columns do I need to use to do the science exploration that I want to do, this is the place for you to do that. And you can see in this case, because these are the COAD images, you have measurements in all of the various bands. So this is in the G band filter, and then you should have all of the same measurements in the I band filter, and et cetera, et cetera. So that's the object table. You see all these other tables here. The source table is the single visit measurements. Again, many columns. So this is your sort of dictionary to look up what columns you might want to use if you're interested in knowing, what the pixel flags are, or how do I get the area of the footprint of each source, or various things like that. This is all available here. So I won't go through any of that in any more detail because I want to get to the science platform, and we have to make sure we leave enough time for that. That was a sort of very quick whirlwind, but at least now you know where to find things. So you can see in this section on DP0.2 data access and analysis tools, there is an overview of the science platform. So you can check that out at your leisure. And then you can see in the next section, we have tutorials. And so for example, if I go, we'll just go here. You can see that we have tutorials on how to use the portal and the notebook, and I'll show you what both of those are now, and also how to do things using the API so that you can access data, remotely, and even how to execute some of the same activities that we have in tutorials from the command line, accessing the science pipelines. So for now, let's just take a quick look at the RSP portal aspect. Again, you have a few tutorials that you're welcome to go through. Let's see, I'm just going to go here. So whenever you want to, .sst.cloud. Whenever you want to go to the Rubin Science Platform, the RSP, you will go to data.lsst.cloud. And this is what it will look like when you land there. And so now you see the links. Each of these large boxes is a link to either the notebook aspect, the API aspect, or the portal aspect. So if I click on those big box to the left, it will take me to the portal aspect, but not until I have been authenticated as a known user. Hopefully this doesn't ask me for my password. It does. You get to watch me struggle to type my password. But you can see I've used ORCID as my main authentication. But you can, if possible, I would recommend using your institutional identity. But you can use ORCID, you can use GitHub, other things like that. Okay, and now I'm authenticated, and this is the portal aspect. And so basically the portal provides you access to catalog data. And you can see here, this is the DP0.2 data that are available. And you can see those various tables that I showed you before are all accessible here. So you can change to query the source catalog instead if you'd like. Instead of the object table, you could go and look for difference imaging objects, for example. So these are all available here. And you can see when you select one of those, this box with the various the options to select different columns for your query appears. And one nice thing about this is it sort of acts kind of like the schema browser that I showed you a minute ago, where if you say, okay, what does this column mean? If I scroll to the right, that description, this is the same description that you see in that schema browser, is here. So you can actually, I have to stretch this so that you can read the whole thing, but you can actually see the column descriptions here. So this can also be a quick way to find, oh, which columns do I want? Oh, let's go to the portal and try that out. So let's say, for example, well, you can see before I type in here, you can see example queries. So I'm just going to do a simple spatial query that will just do this recommended one where we search around a position at RA deck of 62 minus 37 degrees. And you can see by default here, it defaults to 10 arc seconds. I don't know, let's make it 30 arc seconds. And then, there are other, you can do temporal queries if you want. We're not going to do that right now. So if I just select this, I can click search here and it'll go ahead and execute that search for me. Or if I want to, and in fact, it wouldn't do much for me because I haven't selected any columns that I want it to return. So let's say I want some RA and DEC and let's say a G-band flux and its error, for example. I don't know, we're just going to select that many for now. So then I can click search and it will return the results from that. But I can also go here and say populate and edit the ADQL. And that will take me to the same place as clicking this box at the upper right. You see if I click edit ADQL, it takes me here. But if I do this, this will populate basically the query that I've set up. It'll show you what that looks like in ADQL, which is the astronomical data query language. And that's the language. It's like SQL, if you're familiar. This is what you actually use, or is what actually is executing the query. So you can see it's just a database query saying select the RA and DEC and the aperture flux and its error. Those are the columns that I selected from the object table where it is within this many degrees of that RA DEC position that I gave. And so then once you get here, you can edit it too. You can say, oh, and I want to add our aperture flux, say. And now if I go and execute that, since we're short on time, this isn't going to be the most interesting or exciting query. But you can see what it looks like when you execute a query. So now you've got 453 objects in that 30 arc second radius, and you see them on the sky here, overlaid on a sky map of the simulated images. Those are all of the objects. Some of them are visible here as bright galaxies. And then you see this plot. By default, what pops up is a plot of just the first two columns from your query. So in this case, you got RA and DEC, nifty. And you can see that I can select objects from that, and then they are highlighted in the table and in the image. And if I want to edit this plot, say I want to plot these two fluxes instead, you can go to these icons up here are all menus that will give you options to manipulate the tables or plots. So, for example, when I click on this double gear thing, it brings up modify trace, and I can say, okay, instead, and when I start typing, it autofills. When I said G underscore, it brought up the flux column. And let's say I want to plot it as a function, I mean, this is not going to be a very interesting scientific plot, G and R flux. And I can even put error bars on since I did extract the errors. You know, and you can click these arrows here to open up more options to, you know, modify the titles, the min-max ranges, reverse the axes, other such things. We won't get into that in detail right now, but there's my exciting plot of G-band flux versus R-band flux. Oops, that's not what I wanted. So, you know, I can, oops. I can zoom in on this region, for example. So, and there are a lot of things you can do with the portal aspect. It's great, as you can see, it's great for sort of exploration, sort of quick data exploration when you just want to see like what's around in this area of the sky, or I want to find a certain set of sources, and you want to be able to interactively sort of play around and explore. The portal is really great for that. For sort of more detailed scientific analyses, you might want to go to the notebook aspect, which I'll show you very briefly in just a minute. I can show, as Bob requested, I can show how to access data preview 0.3 data as well in the portal. Oops.
I think it can show, yeah, right here, the show to the right.
Yep. There we go. Thank you. So this, yeah, you'll note that that bar that just showed up at the top is hidden initially. So you see hide is highlighted here. When you click show tap services, this gives you the option now. There's a drop-down menu to switch, because it's a completely separate database, the DP0.3 data. So you can switch to accessing DP0.3, and now you can see the interface is the same, and you have your DP0.3 catalogs here, and these are different catalogs, which we'll come to in just one second. So that's how you switch between the DP0.2 and 0.3. So this will be, again, short on time, but I just wanted to note also, I don't want to give DP0.3 shortchange it. The site looks a little different than the DP0.2 one, but this has similar information about the data products and the simulation that went into DP0.3 as the one that the DP0.2 had. So DP0.3 is a simulated set of solar system data products. And so this consists of solely of catalog data. So it's catalogs of solar system objects, like with, you know, observing cadence and such, like what we will see from LSST. And so you can learn all about, and again, this was provided by the Solar System Science Collaboration, which reminds me I need to come back to science collaboration maybe. So you can read more again about the data products here. And as with the DP0.2, we have the data products definition document that tells you about the 4 catalogs that are available to you. You have sources detected from difference imaging. You have solar system source table, and solar system object table. Again, remember, when we say source, we always mean in the single visit images, and object means built up over a large set of images. And then you have the MPC orb, which is the Minor Planet Center orbital information, like the orbital parameters and information that is derived from the data products. So there's more information about all of those here, and how to access those data. Oops. And as with DP0.2, we have tutorials for DP0.3 as well. So there are a few using the portal, and then there are a few using the notebook aspect. So since I've mentioned the notebook aspect and haven't gone there yet, I would like to we'll just use a new window. I would like to demonstrate really quickly the notebook aspect. So just a reminder, when you want to go to the RSP, you always go to data.lsst.cloud. This is your landing page. You can see I'm already authenticated now since I signed in before. You all watched me put my password in. So instead of the portal, this time we're going to go to the notebook aspect. So if I click this big box, it brings up something like this. Typically, you'll just want to use the recommended version of the science pipelines. This image is just referring to the which version of the Rubin science pipelines is going to be loaded by default in your container. So typically you will want to use the recommended one, but if you have a need to use some other one, you can select different ones. And this is just the size of the container that you'll be using, so that basically it just sets the sort of amount of compute and the amount of memory that you have available. I always sort of default to medium. On rare occasions, you'll need a large. If you know you're just doing something quick, you could select small. So once you select that, click start. Excuse me. You'll see this when your server's starting, and soon you shall see a file browser and the option to either start a notebook or open up a command line interface, for example. So actually, let's put it in by default. It will not be in dark mode. So let's put it in light mode. That was just in the settings. You can change to dark mode, which I often use, but we'll put it in light mode. Okay, so when you first log in, you will not have as many folders as this or files. I have a lot of stuff here, but everyone will have in their home directory when they log in this notebooks directory. And when I click that, you can want to show. There we are. You can see tutorial notebooks within this, and this is constantly kept up to date. So if we make any changes or updates to any of our tutorials, those are pushed daily to the science platform, and yeah, always kept up to date. So this shows you, again, it's hard to see all this. There we go. This shows you the list of all of the available tutorials, which you can also see if I go back to our GitHub page. There is the tutorial notebooks repository here on GitHub that you can see all those notebooks available, but you can also see descriptions of what is, sort of a brief overview, as well as, if you scroll even further down, more detailed description of the data products you'll interact with, the skill set you'll be developing, and other such things. So this can help you find which ones you want to go through. course, you're encouraged to just go through all of them. One thing I will remind you about the tutorial notebooks is because this is constantly updated, it is a read-only folder from the user perspective. So, so you won't be able to, if you open one of these notebooks and execute it and make some changes, you won't be able to save those changes in this folder. So it's suggested that you move the file to a different folder if you want to be able to save any changes that you make. I'm going to do it from the command line. I don't want to waste our limited time on showing you how to move files, but let's say we want. I just copied notebook 1, the introductory notebook, to my home directory. So you see it here. Okay, so now when I double click that, it will open up something like this. I'm going to close the file browser over here. And so this is what our tutorial notebooks look like. We don't have time to go through them in detail today, but just to show you the types of things that are here, we have a lot of language here explaining what we're doing throughout. And this is the introductory notebook, which we're just going to get to the part where you see data, because that's the fun part. I'm going to keep going. Okay, so just to show you very quickly, the tap service, remember I showed you that ADQL query earlier. You will use ADQL queries to access the tap service. That's the table access protocol, which is the database, the service that goes and fetches things from the database. So that's what we'll typically use to access data, to access catalogs of data. And so you initialize that service, and let's skip by these, and get to the part where we actually retrieve some data. And again, we'll pick some coordinates, and then here you see that ADQL query that you'll use to actually get data. So I just executed, I said, here's the query I want, and now service.search, execute that query and return a table. And I can add some, this is just converting the fluxes to magnitudes. And then you can see here's my table of data that I retrieved. And you can do that again for, in this case, select the top 10,000. But let's, oh yeah, we probably need more objects. I'll do the 10,000. To show you then, so you're in the notebook aspect, you are executing Python commands in these cells. So so you can make plots, you can do analyses, like so. For example, here's a color magnitude diagram of those 10,000 objects that we selected. And so, okay, it raises questions to somebody who's a Milky Way scientist like me, but this is an artifact of the simulation, these stripes. Yeah, this is just to show you that this is this type of environment you'll be working in. And I won't go any further with this because we have only a couple of minutes, and I want to see if there are any other questions. Oh, I see some messages in the chat now. Maybe I've.
I think everything in the chat's been resolved.
Excellent. Yeah, were there any other questions that anyone else had? Sorry, that was a whirlwind, but we do have a lot of these tutorials, notebooks, and portal tutorials that you can go through. You'll also see links to videos from our past assemblies that have been recorded, so you're free to watch those. And in fact, I'll show you where those are. We go back to. You'll see in the schedule of virtual events here. This is our upcoming schedule, so I encourage you to drop by next week, same time next week. And then the week following, on the 21st, we'll have a tutorial about uploading tables to the portal aspect. We have a DP0.3 phase curve analysis tutorial coming up in April. So this is the upcoming schedule, and you can see right above it, there is a link to past delegate assembly recordings. And so that takes you to this page where you can actually go here. This should be taking you to the recording on YouTube. So if you want to see any of the past, you can see some of these were led by community science team members, and some were led by community members who've contributed science explorations. So that's where you would access those. And one last thing I wanted to mention before we continue is just to remember to join us next week if you are interested. This will be a Q&A open forum time next week. So and come with ideas of things you might want to work through in a breakout room with your colleagues, or any questions you might have. And we look forward to seeing you at future Rubin Science assemblies. Thanks for your time. I know we're at the hour now, so I don't want to keep anybody, but if anyone has any questions, I'm happy to take any questions for the next couple minutes.
Thanks, Jeff. That was great. I'm still responding to questions in the chat as well as we wrap up.
Super. Thanks.